Because we have two samples, we'll need to choose a standard error that gives us a good comparison of both. The simplest thing we can do is calculate what is called a pooled standard error. Recall that we'll measure the number of users who click in each group, which we'll call X control and X experiment, as well as the total number of users in each group, which we'll call N control and N experiment. Now the first thing we'll calculate will be what's called the pooled probability of a click. And I'm using a hat here because this is an estimated probability. And the pooled probability is the total probability of a click across groups. That is, the total number of users who clicked divided by the total number of users. Then we'll calculate the pooled standard error, which is given by this formula. Now recall that we're going to estimate the difference between P experiment and P control, and I'll call this difference D hat for difference. Under the null hypothesis, D, the true difference, is equal to 0. Then we would expect our estimation, D hat, to be distributed normally, with a mean of 0 and a standard deviation of the pooled standard error. If the estimated D is greater than 1.96, our z-score, times the pooled standard error, or less than the negative of this cutoff, then we can reject the null hypothesis as unlikely, and say that our difference represents a statistically significant difference.